And there is another difference about this new push for the moon. Private companies are also involved. In the UK, a small satellite manufacturer is helping with communications infrastructure. Surrey Satellite Technology was founded in 1985 by spacecraft pioneer Professor Sir Martin Sweeting. The Apollo missions were very much a geopolitical event. They were about who was more dominant, the United States or the USSR. What's going on today?
I'm actually a child of the Apollo era because I watched the moon landings when I was an early teenager, and that's what stimulated me. But things have really changed a lot because, first of all, space now includes much greater participation of the private sector. It was, in the early days, primarily a geopolitical, very strongly military-inspired exploration and activities in space. But in the last decade, the private sector has taken an interest in this because they see the potential for a lunar economy, and also supporting some of the government aspirations for long-term lunar bases. And so the whole thing has changed. And yes, there is a bit of a race because there are now lots of players that are all jostling to participate in this.
I was fascinated to hear you use the phrase, the economy of the moon. It sounds like it's going to be a very busy place.
Well, if you have a look over the next, I think, 10 years, there's something like 100 different missions being planned to go around the moon, some of them on the moon, either for exploration or for scientific purposes, and the potential for an economic activity on the moon. Now, exactly what that's going to turn out to be and how profitable it will be and what sort of economy is going to support, I think is probably an open question at the moment. But the potential for that is seen particularly by the private sector.
How does what you're doing here fit into all of that?
Well, this is a very, very small bit of what which we're trying to contribute into this. And the first, we have a mission called Lunar Pathfinder, which is a first spacecraft which is going to provide commercial services around the moon. So if you think about it, you have mobile phone networks and you have navigation satellites providing us with navigation on Earth. We're going to need the same on the moon. Every crater looks much the same on the moon, so you're going to need your GPS or your Beidou on the moon to be able to find your way around. And the whole purpose of Lunar Pathfinder is to create the opportunity to see how all of this works and to make the first steps and to learn, because I'm sure we won't get it all right in the first instance, and of course to provide services to other international players.
International, such as China? How does China fit into all of this?
Well, of course, China has a very ambitious and capable lunar exploration program. They have the Chang'e 4 and, of course, its predecessors. They already have a relay satellite, and we would like to see, if possible, collaboration with China on this and providing perhaps additional services to support their ambitions, as well as other international players.
Sir Martin Sweeting sees future lunar bases modelled after those in Antarctica, where nations establish independent facilities while fostering coordination and collaboration supported significantly by private enterprises. The SSTL Lunar Pathfinder satellite will be the first of a constellation of interconnected lunar orbiters that will provide data relay services for communication and navigation around the moon. So Lily, where are we?
So we are currently in the AIT clean room.
Which is why we're in this glamorous outfit.
And you do look fabulous,
Thank you very much.
And this is Lunar Pathfinder.
Forgive me, but it looks a bit like a flat pack satellite.
Yes, you'd usually expect it to be in a bit more of a boxed state.
Yeah.
But imagine the origami cubes you used to make as a child. You just sort of fold it all up and
so
it all
this is going
together.
To come up here.
Yep, and this one will come up this way.
Right.
And then we'll have a base plate, a top plate, and then a solar array closure panel that will go on the front.
These buttons, I know they're not buttons, but they're fascinating. I really want to touch them.
Please don't press them.
What are they?
These are our star trackers. So they'll look out to constellations. They'll be loaded with a specific map when we launch, and then they'll look at the angles off those stars. Almost like, imagine what you had on ships in medieval times, where they're looking at different sextants with their stars. And it'll be doing that in the module.
So what's this magnificent beast here?
So this here is our onboard computer and the data recorder, so the brains of the spacecraft.
And how do you control the attitude of this thing when it's in space?
So we have two methods. We'll be firstly be using a propulsion system, and secondly we'll also be using our normal AOCS or attitude orbital control systems, such as reaction wheels and gyros.
Can we see one of those wheels?
Oh yeah, absolutely. So we've got this is the mass dummy of one of our wheels.
Oh, that's quite a lot of mass. That's about 3 or 4
yeah,
kilograms.
They're rather heavy.
Yeah.
And then we'll have 4 of those distributed across the spacecraft.
So that goes, if you move that like that, the inertia of this changes the attitude of the spacecraft.
Yes, so this itself will stay still, and then there's a sort of a wheel inside it that will be moving.
Oh, so this isn't the final thing?
No, this is just the mass dummy.
A mass dummy oh, right,
Yeah.
I understand.
If it was a real thing, we wouldn't be handling it in this way.
Ah, good point. When I look at this, I'm getting a real buzz out of thinking this is going to be in space in what, 2 years?
Yes, around that.
How does it make you feel?
It's extraordinary. Every job has its highs and lows, and sometimes you're sat behind the computer screen sending emails or in a meeting, but then you come down here and you go, this is going to go around the moon. And then you'll leave at the moment because it's winter. You'll leave and the moon's up and you go, that's where it's going. It's going to the moon, and you just have to pinch yourself ever so slightly. Really quite cool.
Professor Sweeting talked about an economy on the moon that this will contribute to, helping people communicate, helping people know where they are. If you had the chance, would you go and join that lunar economy?
I'd be in two minds. Part of me would say absolutely yes, because if you're given the chance to go to space, why would you say no? But secondly, I don't think I could leave my dog behind.
Not to mention it would be terrifying.
It would also be terrifying, yes. The launch itself, it's difficult to go to space. But if you can help put forward for the human race, as we move on to the moon, and then through going to the moon, looking forward to going to Mars.
Do you see the future of the moon or even space in general? Do you see that as collaborative or competitive?
The future, it has to be collaborative regarding agencies and getting everyone to pull forward in the same direction. There will always be a side of competitiveness within the commercial market. If you don't have small companies working against each other to better each other, then you won't develop the technologies with the speed and agility that you need. But it's the agencies collaboratively. We just have to work together to work along these same frequency guidelines, space recommendations, outer space treaty, for example. And that's where we need to be collaborative, because we are, tiny human beings on a rather small planet orbiting a sun in a solar system that doesn't really see us. So we need to remind ourselves we need to work together to make sure that we are all pulling in the same direction. It has to be collaborative.